This sulfur dioxide is a very powerful oxidizing agent. It can oxidize certain metals like potassium, sodium, magnesium, and also it can show reaction with hydrogen sulfide. Let's take example and understand this. For example, if you take magnesium, that is 2 Mg, if heated with SO2, it will give you magnesium oxide, MgO. That is, addition of oxygen takes place. That is why it is called oxidation along with sulfur. Whereas with respect to hydrogen sulfide, that is 2H2S plus SO2 will give you sulfur along with water. That is removal of hydrogen, again indicating the oxidizing nature of sulfur dioxide. This sulfur dioxide can also be acting as a strong reducing agent. So, sulfur dioxide can be an oxidizing agent, at the same time a reducing agent. Reaction involving in reduction is addition of hydrogen or removal of oxygen. Let's see reduction by addition of hydrogen. In presence of moisture, sulfur dioxide liberates nascent hydrogen. That is, SO2 plus 2H2O will give you H2SO4 along with 2 nascent hydrogen written in brackets. Now, reduction by addition of hydrogen, example, turning iron 3 salts to iron 2 salts. That is, reducing the valencies. For example, take Fe2SO4 thrice treated with 2H2O plus SO2 will give you 2FeSO4 plus 2H2SO4. The solution turns brown to green. Now, let's take few examples and understand the properties of SO2, that is the reducing property. To begin with it, let's take chlorine water. Now, what is chlorine water? Cl2 along with 2H2O, pass SO2 gas through it, you will get HCl, that is hydrochloric acid, 2HCl along with H2SO4. Similar manner, you can take bromine also, treat it with H2O in presence of SO2 gas, you will get HBr acid along with sulfuric acid. You can also show the reaction as we had already indicated by iron 3 sulfate, that is Fe2SO4 thrice along with 2H2O plus SO2 giving us 2FeSO4 plus 2H2SO4. We can show it with iron 3 chloride, that is 2FeCl3 plus 2H2O plus SO2 will give you 2FeCl2 plus H2SO4 plus 2HCl. In case of chlorine water, the pale greenish yellow solution reduces to hydrochloric acid, which is colorless. In case of bromine water, it is reddish brown solution. It reduces to hydrobromic acid, which is colorless. In case of iron 3 salts solution, reddish brown color reduces to iron 2 salts, that is greenish or yellow. Similar manner, we can show the reducing property of removal of oxygen by using substances such as potassium dichromate, which is orange in color, K2Cr2O7, treated with sulfuric acid, H2SO4, acidified it, along with 3SO2, that is sulfur dioxide gas passed through it, will give you chromium sulfate, that is Cr2SO4 thrice, which is green in color. That means orange turns green, along with K2SO4, along with H2O. This can be one of the tests of testing SO2 gas. Taking potassium permanganate, that is 2KMNO4, which is pink or purple in color, along with water, that is 2H2O, with 5SO2 gas, will give you manganese sulfate, that is 2MnSO4, which is colorless, so pink color changes to colorless, along with K2SO4, along with 2H2SO4. This also can be used as one of the tests for testing sulfur dioxide. If we take nitric acid, 2HNO3 plus SO2 will give you 2NO2 gas, that is reddish brown gas of nitrogen dioxide, along with H2SO4, that is sulfuric acid. This also can be one of the tests of testing SO2 gas. Sulfur dioxide can be used as a bleaching agent. It bleaches by liberating nascent hydrogen. That is, bleaching action of sulfur dioxide is due to reduction. If we take sulfur dioxide gas and pass it in water, that is 2H2O, we will be getting H2SO4 sulfuric acid along with 2 nascent hydrogen, that is 2 in bracket you write H. Now this sulfur dioxide, which is a colorless gas, it is bleaching by reduction. Take any coloring matter and bring it in contact with nascent hydrogen. This bleaches it. That means this nascent hydrogen reacts with the coloring matter and removes oxygen from the coloring matter, and it reduces it and it becomes colorless. But then again, if you take this coloring matter or the organic compound, put it in the air again, oxygen will be added and you will regain the color. So bleaching action of SO2 is a temporary phenomenon. So any coloring matter, that is any vegetable, in contact with nascent hydrogen, removal of oxygen takes place, that is reduction, and it becomes colorless. It gets bleached. There is a slight difference between the bleaching action of chlorine and the bleaching action of sulfur dioxide. In case of bleaching action of chlorine, it is a permanent bleaching, whereas in case of sulfur dioxide, it's a temporary bleaching. In case of chlorine, it is a strong bleaching agent used for rough clothes like cotton, jute, etc. Whereas it's in case of sulfur dioxide, it's a mild bleaching agent used for delicate clothes like fabrics, silk, wool, straw, etc. Both of them require moisture to liberate nascent oxygen and to liberate nascent hydrogen. So bleaching action of chlorine is by oxidation, whereas in case of sulfur dioxide, it is by nascent hydrogen. We can test the presence of sulfur dioxide by various reactions in the laboratory. To begin with it, we can take potassium dichromate, which is orange in color. To this, first we acidify it by putting 1 or 2 drops of sulfuric acid and then passing sulfur dioxide gas through it. The observation of yours will be the orange color changes to green because of the formation of chromium sulfate. The reaction for this test goes as follows: K2Cr2O7, which is orange in color, plus H2SO4 along with 3SO2 will give you Cr2SO4 which turns into green color, plus K2SO4 and H2O. Similar manner, you can test it with potassium permanganate, KMnO4, that is 2KMnO4, which is purple in color, along with water, 2H2O, along with 5SO2, that is sulfur dioxide gas, giving you MnSO4, 2MnSO4, which is colorless, along with K2SO4, along with 2H2SO4. Not only that, you can test it by using chlorine water. What is chlorine water? Cl2, dry chlorine gas, along with 2H2O water, passing SO2 through it and putting barium chloride in it, that is BaCl2. We will be getting a white precipitate, insoluble precipitate of barium sulfate, that is BaSO4, indicated by an arrow downward, along with 4HCl. You can test it with moist colored flowers. When it is brought in contact with SO2, it gets bleached. But this bleaching action is due to reduction, that is removal of oxygen. If you put HNO3 in it, that is dilute nitric acid, which is a very powerful oxidizing agent, it will supply oxygen to the bleached flower. As a result, it can regain its color. Not only that, it can also be used in paper industries. It can also be used in bleaching sugar, refining sugar. Not only that, it can be used as a bleaching agent for bleaching delicate fibers. It can be used as anti-chlor. You know what is anti-chlor? It removes excess of chlorine from a bleached article. It can also be used in preserving liquid food. Reason? It kills bacteria and prevents the oxidation of liquid food by removing oxygen. It can also be used as a disinfectant, that is, household fumigant. This sulfur dioxide you must have studied in your lower standard. The various applications like using in fertilizer, for preparing so many sulfur drugs, and you must be knowing about SO2, a colorless gas. SO2 gas, which when passed through slake lime turns lime water milky. Now let's start with a very important compound, and that is the king of chemicals, that is sulfuric acid. Let's see how it is prepared and what are the properties of it. To begin with it was initially or in olden days known as oil of vitriol. Reason for that? It was prepared by distilling green vitriol. You know what is green vitriol? It is FeSO4.7H2O. Later on, it was prepared by heating metallic sulfate like aluminium sulfate in the absence of air. Occurrence part of it, sulfuric acid, can occur in both the forms, free state as well as combined form. In free state, it is obtained in minute traces in hot springs, whereas in combined form, it occurs as many metallic sulfate. Now, how to prepare such an acid which is so dangerous? It can be prepared in two ways. One, the general method of preparation. Second, on a larger scale by the process called contact process. To begin with it, let's see some of the general method. In the beginning, you can obtain sulfuric acid by heating nitric acid with sulfur. The reaction for this will be S plus 6HNO3 concentrated will give you 6NO2 plus 2H2O plus H2SO4, that is sulfuric acid. Not only that, you can also prepare sulfuric acid by passage of chlorine through an aqueous solution of sulfur dioxide. The reaction for which will be Cl2 plus SO2 plus 2H2O will give you 2HCl plus H2SO4. You can also prepare it by reaction of or dissolving sulfur trioxide in water. The reaction for which will be SO3 plus H2O will give you H2SO4. You can prepare by one more method, and that is hydrolysis of sulfuryl chloride. SO2Cl2 is known as sulfuryl chloride. When dissolved in water, 2H2O, it will give you H2SO4 plus 2HCl. Now, to begin with contact process, it's a major process of preparing sulfuric acid on a larger scale. It involves 4 units. First, production of sulfur dioxide, which involves 2 of them, and that is a blower through which we pass air or oxygen. Second is sulfur or pyrite burner, in which we have placed sulfur or iron pyrite, which is going to be burned in order to get sulfur dioxide. Then we have second unit, and that is purification unit. In this case, the gaseous mixture of SO2 and O2 is purified by removing impurities. Now, the following steps are involved in it. First is the dusting tower. This dusting tower removes dust particles by downward blow of steam. Second is the cooling pipe for cooling the gas by passing through isolated pipes. Third is the scrubbing tower. This scrubbing tower removes further impurities by passage of water or a spray of water. Then comes the drying tower, in which we dry this moist gas by the downward spray of concentrated sulfuric acid. Then comes arsenic purifier. In this case, arsenic oxide, the impurities are removed by passage over ferric hydroxide. And last comes the testing box. In this testing box, the gases are tested for any impurities present even in traces. Then comes the third unit, and the third unit is catalytic oxidation. In this case, SO2 gas, which is formed is further getting oxidized to SO3, that is further getting converted into SO3 by passage of sulfur dioxide and oxygen through iron tower packed with vanadium pentaoxide. Vanadium pentaoxide, a catalyst which has been initially heated to about 450 to 500 degrees Celsius. It's a reversible reaction. The pressure maintained here should be optimum, that is between 1 to 2 atmospheric pressure. According to Lee-Chatler's principle, low temperature and high pressure will favor the forward reaction, that is formation of SO3. But if you take the pressure very high, then no doubt you will get more of SO3. But this SO3 which is formed may damage the lead pipe and acid resistant tower. At the same time, it will decompose the porous catalyst. So we should maintain an optimum pressure. Now comes the fourth and the final unit, and that is absorption of SO3 in the absorption tower. Sulfuric acid concentrated is introduced from the top so that SO3 gets mixed up with it and we get an acid called oleum, that is H2S2O7. Now, even though sulfur trioxide is an acid anhydride of sulfuric acid, it is not directly mixed with water. Reason for that is it is an highly exothermic reaction resulting in the production of a dense fog and acid particle which do not get easily condensed. So we should use sulfuric acid. Now this sulfur trioxide vapors will get mixed up with sulfuric acid and we get oleum, that is H2S2O7. Now this oleum is further diluted in a dilution tank with the required amount of soft water and we get 98% concentrated sulfuric acid, that is H2SO4. Now the various reaction which takes place in different units are as follows. To begin with it, the first reaction takes place in the sulfur or pyrite burner, where if you have kept sulfur, sulfur will burn in excess of oxygen forming SO2, that is S plus O2 giving you SO2. If you have taken iron pyrite, the reaction will be 4FeS2 plus 11O2 giving you 2Fe2O3 plus 8SO2. Then the next comes the purification tower. After the gas getting purified, it will enter into the contact tower. The next reaction takes place in contact tower, that is 2SO2 sulfur dioxide gas plus O2, reversible sign. It's a reversible reaction in presence of vanadium pentaoxide, that is V2O5 as a catalyst, 450 to 500 degrees Celsius, pressure 1 to 2 atmospheric pressure. It will form 2SO3, that is sulfur trioxide. Along with that, since it is an exothermic reaction, it will give out 45 kilocalories of energy, that is heat. Then in the absorption tower, SO3 gas is mixed with H2SO4 to give you H2S2O7, which we call it as oleum or also known as pyrosulfuric acid. Then comes the last one, and that is in dilution tank. In dilution tank, H2S2O7, that is oleum, gets mixed up with required amount of water, H2O, soft water, giving us required amount of sulfuric acid, that is 98% concentrated, 2H2SO4.